Hi, my name is Aubrey Tesserolo, and the title of my project is Canine Brain Wags. I chose this title because I thought it'd be appropriate due that my topic is what angle does a dog's tail wag on when they see different stimuli. And I chose this topic because I was really interested in I wanted to know what caused the different tail wags, because with their ears they go back, or they do ears when they're happy, and or their tail goes down when they're nervous. But I wanted to see what angle the dog's tail wagged on when they saw different stimuli. The purpose of my experiment is to discover what the dog's brain does when seeing different stimuli and how that affects the tail wagging. I will also find out if the angle of the dog's tail wag is controlled by different sides of the brain. My procedure was, I collected 10 dogs, which was fairly easy because most of my friends have dogs, and then I did an instructional video to describe what to do. What you did is you got a crate and you covered the top of the crate with a blanket. After you did that, you would make sure that there's no signs peeking out, because you don't want the dog to be able to be distracted when you're testing them, so you know that your results are accurate. Then the dog goes in the crate and you put the first stimuli out. But before you do that, you get a camera and record the top of the crate to make sure you can see the dog's tail wag. Most people put it underneath the blanket or held it there and left a little square above the tail. Then you would put the stimuli and remove the front sheet of the crate so the dog could be exposed to it. I left it there for about 30 seconds to a minute, but with my videos, I did different lengths. For the cat video, I played it twice because it was a bit shorter, and the dog video was just once because it was about a minute. Next, I videoed the dog, and then after that, I let them out of the crate and I praised them or gave them treats depending on, just depending, because some people praise them with just praise and some people praise them with treats. Then I repeated that 4 times with all the dogs. Unfortunately, because of COVID-19, I was unable to do it myself, so I had to get their owners to do it, and lots of the time the tails did not wag due to the fact that lots of the stimuli was not in person. The only one that was in person was the owner, and almost all the dog's tail wagged for the owner. For my test results, I made tables. So basically what it looks like is it has the dog's name, what dog they are, the date, and then I said the owner, what they did, and I described everything for the cat video, the dog video, and every my person, any other notes that I didn't think would be appropriate to put in a specific category. What I discovered in my results is that if the dog's tail did wag for the owner, almost all of them wagged towards the right. So in my hypothesis, when I hypothesized that, I was correct. People who would benefit from using these results in the real world would be vets, vet techs, animal trainers, specifically dog trainers, and owners. Vets would be people who would be doing either dog brain surgery or just would need to learn about brain lateralization. Vet techs would be the same. But it would be very important for vet techs too, and animal trainers, and owners, and vets, so for all of them to know that if the dog's tail is wagging to the left, which means that they are unsure, unfamiliar, nervous, and just very scared, that means that they would need to stop what they're doing and they can try again later. But if the dog's tail is moving to the right, or very quickly to the right, or all over, that would mean that they're happy and they continue on doing whatever they're doing because the dog is happy and they like it. But it would be if they push the dog too far when the tail's going to the left or down, quite frankly, the dog would be very nervous and would probably get afraid of that thing that they're doing. So that's how they would benefit. The first part about my project was probably the experimenting. It was very chaotic because one of my dogs dropped out at the last moment and I had to find another dog very quickly. But also, lots of the dogs that I tested did not have crates. Just my neighbors had dogs. Not all of them had crates. So I had to kind of problem solve and think, okay, like, how about we use a pillow? If we make a block of pillows and then put a blanket over top, will that work? So some of the dogs that do not have crates and were put in a crate and they're not familiar with it, they were very anxious or scared. Also, I was very stressed because lots of the dogs did not wag their tails. And later I found this out that it was, most likely it was caused because none of the stimuli was in person except the owner. And almost, like most of the, over 50% of the dogs wagged their tails when they saw their owners, which I was like, okay, that's good, yay. But then when they didn't wag their tails for any of the other ones, for the dog video, cat video, or the unfamiliar person, I was very stressed and I was like, why is this not happening? Like, project's not working. But I found this helpful because now I learned how to problem solve through that and how to just like, that was the outcome of my project. We were just experimenting to see what would happen, and now I know that that's what happened. And so on that note, some further research that could be done in this project, in this experiment, is more research on how the dog's brain reacts to screens. I know for my dog, for example, sometimes she watches the TV when it's on, if there's like barking or big bang or anything, something like that. And I find that kind of interesting, and I kind of want to know, like, do they not like know what's happening on the screen or anything like that? Because, well, they didn't really wag the tail at all, so it would definitely be how the dog's brain reacts to screens and what is like their thought process throughout that. How I use a scientific method in my project was I did it step by step. So my teacher kind of said, okay, here's the due dates for everything, and we're going to work on this, and then this, and this. And then you had about a week of an extension if it was late, and then you would just focus on one thing at a time. I found that very helpful because if we did not do the scientific method and did it one step at a time, like focus on this week, okay, that's done now, move that aside this week, until the very end when everything's done. If we did not do that, I would have been very stressed and I'd be like going crazy. I'd be working on it like throughout the whole thing. I'd probably actually work on like the conclusion and like the big slideshow, like the presentation board before I was even done the experimenting my project. Thank you so much for watching. I had so much fun doing this project. It was a great learning experience, even though all my testing didn't go as planned. That's part of doing a science fair project.